Good evening, class. We are looking at Chapter 11, Sequences and Series. Here, Section 11.1, Sequences and Series. So in this chapter, we're going to cover sequences and series, arithmetic sequence and series, geometric sequence and series, the binomial theorem. This has been covered in college algebra. The objectives are: write the terms of a sequence defined by an explicit formula, write the terms of a sequence defined by a recursive formula, use factorial notation. Reminding everybody of conics, a circle is a set of points in a plane that are the same distance, called the radius, from a fixed point called the center. X squared plus y squared equals r squared, or x minus h quantity squared plus y minus k quantity squared equals r squared. An ellipse is a set of points in a plane, the sum of whose distances from two fixed points is a constant. The length of the major axis 2a or 2b. The two fixed points are called the foci. Each is a focus of the ellipse. F1 and F2 represent two foci of an ellipse. The formulas are x squared over a squared plus y squared over b squared equals 1. Or if it's centered differently, is it centered at 0, 0? It's x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. If a is larger than bc squared, is a squared minus b squared. If b is larger than ac squared, is b squared minus a squared. And the area is pi ab. And again, it's a pair with coordinates x comma y, so pf1 and pf2. What is a hyperbola? A hyperbola is the set of points in a plane, the difference of whose distances from two fixed points, called the foci, is a constant for every point on the hyperbola, the difference m minus n. So you pick a pair and connect it to the two foci. The difference is fixed for every point on the hyperbola. The difference m minus n is the same constant. A hyperbola has two vertices. The vertices are the points where the graph crosses the x or y axis. Center the point halfway between the two vertices, and transverse axis, the line through the vertices, is called the transverse axis. The formula is similar to an ellipse. However, there's a difference instead of addition here. X squared over a squared minus y squared over b squared equals 1. If it opens up and down, y squared over b squared minus x squared over a squared equals 1, where a squared plus b squared is c squared regardless. And asymptotes of y equals plus minus b over a times x. Notice I keep the a squared in both cases under x squared. And if you go with that, it will help with the rest of it. And of course, if it's centered differently, as a different formula. And again, the idea is that the difference p f1 and pf2 is a constant. In this case, if this is a, is 2a. Parabolas and the concept of a lattice rectum. A parabola is a set of points in a plane that are the same distance from a fixed point, called the focus. So pick a point and connect it to the focus, drop a perpendicular to the directrix. They must have the same distance, called the focus, and from a fixed line, called the directrix. As a result, parabola has this form. What is a lattice rectum? The lattice rectum of a conic section is the chord or the line segment through a focus parallel to the conic section directrix, so parallel to that. And it's equal to 4p. The length of the parabola's lattice rectum is equal to 4 times the focal length, so this distance. And you can see here what happens in the proof is very simple. We call by definition the distance d from the focus to any point p on the parabola is equal to the distance from p to the directrix. So this distance is the same as this distance, which makes this distance 2 times p. And remember, this distance is p. And so therefore, since these two are identical, then it makes from here to here 4p. Again, reminding you of what we have seen. And there are different equations that we have discussed. Vertex at 0, 0, opening up or opening down. The vertex at 0, 0, y equals ax squared. A is positive, opens up, negative opens down. Or you can write it in this format, x squared equals 4py or minus 4py. If it opens sideways, again, centered at 0, 0, x is ay squared. A is positive, opens to the right, negative opens to the left, or you can write it as y squared equals 4px, or y squared minus 4px. And focal distance is either p or a. I rather call it p, and the relationship is that a, if we go with this formula, then a equals 1 over 4. So it's good to have those. Y equals 4p squared, y squared equals minus 4px, x squared is 4py, x squared is minus 4py. Depends on how you look at it. And the relationship between p and a is that one of them is 1 over 4 times the other. Okay, so p and 1 over 4a are the same, or a and 1 over 4p are the same. All right, let's go to a new stuff class, and that is sequences and series. Measurements collected at discrete time points and quantities that undergo periodic changes, such as annual plant or insect populations, are studied using the concepts of sequences, the data, and difference equations, the description of the mechanism of change. A sequence is a list of numbers written in a specific order, a sub 1 all the way to a sub n. It is a real valued function f whose domain is the set of natural numbers 1, 2, 3 to infinity. We use the notation a sub n to denote f of n, a sub 1 all the way to a sub n. The first term is a sub 1. The second one is a sub 2, and in general is a sub n. Recursive sequence, or also known as difference equation. A recursion or recursive formula defines a sequence by specifying the first few terms of the sequence and using a formula to specify subsequent terms in terms of preceding terms. The next term depends on knowing the previous one or previous ones. A sub n plus 1 is f of a sub n. A couple of them that we've already seen, and we will discuss them with more details later, are as follows. One of them is an arithmetic sequence. A sub 1, a sub 1 plus d, a sub 1 plus 2d, and so forth, where the difference d, also known as distance, between consecutive terms is constant, can be defined by recursively, a sub n plus 1 is a sub n plus d, or explicitly by a sub n equals a sub 1 plus n minus 1 times d. Example 1, 5, 9, 13, and so on. As you can see, we just add 4, right? So d is 4. So this is an example of an arithmetic sequence. Similarly, a geometric sequence, a sub 1 times r, a sub 1 times r squared, and so on, where each term is r times the previous one, can be defined recursively by saying a sub n plus 1 is r a sub n. That means the previous one times r, or explicitly by a sub n equals a sub 1 or to the power of n minus 1. Example 1, 4, 16, 64. As you can see, we are multiplying by 4. So when we multiply, so in other words, here d is 4, here's r is 4, the ratio they call it. And so in this case, 1 times 4 is 4, 4 times 4 is 16, 4 times 16 is 64, 4 times 64 is 256, and so on. Given the general term, find the first 5 terms. A sub n equals n. We start with a very simple case. The first one is 1. Right. Change. Okay, if this is 1, so is this. A sub 2 is 2. And so just 1, 2, 3, 4, 5. C sub n is n over 1 plus n. So if I want the first one, I put 1 here, I put 1 here, I put 1 here, and I get 1/2. If I want C sub 2, everybody, according to this formula, I put 2 here, 1 plus 2, and I get 2/3. And I'm going to assume you can figure out the rest of it. D sub n equals the digit in the nth decimal place of pi. Please understand, pi is not equal to 3.14. It is approximated by that. So it's 3.14159, and it continues indefinitely. So when we want the nth decimal, okay, so the first decimal would be, let me use a different color here. Nth decimal is, remember what we want. We want the first 5 terms. So the first one would be 1. The second one, 4, so on and so forth. We want how many of them? 5 of them. So 1, 4, 1, 5, 9. Find the first 5 terms of this sequence. A sub n is 2 to the power of n minus 4. So first, we replace this with 1. That gives us -2. That's the first term, everybody. Then we replace it with 2. 2 squared minus 4, 0. So if I want a sub 3 as an example, I want 2 cubed minus 4. 8 minus 4 is equal to 4. I'm going to assume we can figure out the rest. Since we want the first 5 terms, we are going to write the first 5 terms: -2, 0, 4, 12, 28. For a case like this, as long as you can show work for the first, even the second one, that's good enough. But you really have to show work for at least 2 of them to be on the safe side. And I like to do a little bit more, like 3. Find the formula for the general term A sub n of the sequence here. So what do we notice? We notice this is e, then e squared over 2, e cubed over 3, e to the power 4 over 4. You may realize if you put a 1 here, what happens is the denominator is getting larger by 1. So 1, 2, 3, 4. And this one has exponent 1. So in other words, this is e to the power of 1 over 1. And then the next one, so this e to the power of 1, e to the power of 2, e to the power of 3, e to the power of 4, clearly, so let me erase my work. Clearly, it shows that the a sub n must be e to the power of n over n. Not only that, you really have to check it. And the way you check it is very simple, class. Now that you claim this, replace the n with 1 must give you the first one, 2 must give you the second one, 3 must give you the third one, so on and so forth. This is how you check, and I can't emphasize this enough. What about this one? You may notice that the numerators are all 1. So if I put, and this is 3, this is 9, this is 27, this is 3 to the power of 1, 3 squared, 27. So if I put 3 to the power of 0, which is equal to 1. Please understand, everybody, 3 to the power of 0 is 1. And this one is 3 to the power of 1. This is 3 squared. This is 3 cubed. But then b sub n must be 1 over 3 to some power. So, and it's 3 to the power of n minus 1 because when n equals 1, you should have 1 to the power of 1 over 3 to the power of 1 minus 1, which is 1 over 3 to the power of 0. You can check the two. N equals to 1 over 3 to the power of 2 minus 1, which means 1/3. So that checks, and you can check the next one on your own. But you have to check. This one is just a bunch of what? Odd numbers, everybody. Notice they're odd numbers. So C sub n is 2n minus 1. Okay. Odd numbers. Remember, if it were even, would be 2n normally. Okay. Like 2, 4, and so forth, right? 2, 4, 6, 8. So this is 2n minus 1. And you check. If I plug in 1, I get 1. If I plug in 2, I get 4 minus 1, 3. If I plug in 3, I get 6 minus 1, 5. So you must check, because this is one way to represent an odd number. Another way, it could be 2n plus 1. Okay, but 2n plus 1 in this case doesn't work, but 2n plus 1 represents an odd number as well. We are assuming n is a whole number. And so what about 1, 4, 9, 16, 25? You may recognize this as 1 squared, right? So this is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. So it must be square of numbers, or n squared. What about this one? There are two things to understand. The sign alternates between positive and negative. The first one is positive, the second one is negative, and so on. And so we are going to put a 1 underneath this one, okay? So if we ignore the sign, we have 1, 2, 3, 4, 5. So we have something over n. I hope you recognize that. And the numerator is 1. It's 1 over n. If we didn't have alternating sign, and by the way, this is plus, this is a typo, everybody. This is positive 1/3. So we are changing from positive to negative, positive to negative, positive to, so the next one, for the sake of argument, must be negative 1 over 6. So it's 1 over n, but what about the sign here? The sign that alternates, so alternating sign. That means negative, positive, or positive, negative. It's negative 1 to the power of n minus 1, or negative 1 to the power of n plus 1. Okay, one of the two. And in this case, the first term, if you look at this one, first term, n is 1. So if I use it on any of them, it actually works. And I'm going to work on this one. Okay, minus 1 to the power of 1 plus 1 is minus 1 squared, which makes it positive 1. Therefore, let me erase my work. The answer must be this, representing the alternating sign, and 1 over n. So for a case like this, look at alternating sign and how you arrive at the answer. That's how it works, everybody. Pretty straightforward. Difference equation sequences are sometimes created recursively, specifying the next term given the present term. The initial term of the sequence must also be specified. This procedure defines each new term as a function of the previous one. And it may not always be possible to determine the general term of the sequence algebraically. A difference equation, known as recursive sequence, is an equation of the form a sub n plus 1 equals f of a sub n, where a sub 1 is given and f is a real valued function. A solution is a sequence a sub 1, a sub 2, all the way a sub n, satisfying the given difference equation, everybody. So reminding you of actually the definition we had discussed. One of those is a Fibonacci sequence, a recursive that we have seen. F1 is 1, F2 is 1, and then F sub n is F sub n minus 1 plus F sub n minus 2, as long as n is larger than or equal to 3. What does it mean? That means the first two are fixed, some numbers, in this case 1 and 1. Then you add them up. Notice if I add these two, I get 3. I add these two, I get this. Add these two, I get 8. These two, I get this. These two, I get 21. So what would be the next one? This is a Fibonacci sequence. Just add these two. You get 34. That's the meaning of this, okay? It says add two of the previous ones. So f sub 9 is f sub 8 plus f sub 7, and it's 34. Example happened in the nature. The number of branches increases up a tree trunk according to the Fibonacci sequence. So you have one the first year, you have another one the next year, and then becomes 2 because we add these two. The next one we add these two, we get 3. The next year becomes 5. The next year becomes 8, and so on. Let's look at a couple of examples to see how we arrive at the answer for cases like this. We are given a sub 1, some number, in this case 6, and a sub n plus 1 is a sub n over n, and we want 6 terms. So if a sub 1 is given as 6, then what is a sub 2 as an example? So this is 2. That makes this one 1. So it makes it a sub 1 over 1, which is 6. I hope you recognize that. What about a sub 3? So according to this, a sub 3 must be a sub 2 over 2. Let me erase my vote. According to this formula, if this is 3, this is 2, right? Because, or better yet, just choose this one to be 2 and this goes up. So if I want the next one, a sub 4, this must be a sub 3 over 3. So 3 over 3. It gives me 1, and I want you to figure those two on your own later on, because we just showed a bunch of them. So we write 6, 6, 3, 1, 1/4, 1/20. Make sure you can figure this out. We're going to get a couple more examples. A sub 1 is given as 1, a sub 2 is given as 2, a sub n plus 2 is a sub n plus 1 plus 2 a sub n. In other words, if you want a term, pick the previous one, and then 2 times the one before that. A simple example, if I want a sub 3, this must be a sub 2, the one before that, and 2 times a sub 1. I hope you recognize that. And if you don't, just do this. Say, okay, this is 3. If n plus 2 is 3, n becomes what? 1. So put it here. 1 and 1 is 2. Put it here. In any event, now a sub 2 is 2 2 times 1, 2, they add up to 4. Let's find a sub 4. A sub 4 must be the previous one plus 2 times the one before that. A sub 3 plus 2 is sub 2. So that must be 4, and then 2 times 2 gives us 8. What about a sub 5? Should be the previous one, a sub 4. If this is 5, this must be 4, this must be 3. So a sub 5 is a sub 4 plus 2 a sub 3. So a sub 4 is 8, 2 times a sub 3, 4, 8 and 8 adds up to 16, and you can figure out the rest. And you're right. What about a sub n plus 1 equals 2, a sub n minus 4, and a sub 1 is 3? So you have one of them, find the second one. So if I change this to 2, that means it's 1. Or just say, okay, if I put 1 here, this must be 1 more, 2. So a sub 2 is 2, a sub 1 minus 4. So 2 times 3, 6 minus 4 is 2. I do one more. If I said a sub 3, then it's 2 a sub 2 minus 4, which makes it 2 times 2. 4 minus 4 is 0, and you can figure out the rest on your own. A finite sequence is a function that has a set of natural numbers of the form 1, 2, 3 to n, the finite set as its domain, and it ends. An infinite sequence is a function that has the set of all natural numbers as its domain and keeps on going. Notation, we write a sub n is f of n. Convergence and divergent. Convergent and divergent sequences. A convergent sequence is one whose terms get closer and closer to some real number. The sequence is said to converge to that number. A sequence that is not convergent is said to be divergent. Limit refers to the long-term behavior of a sequence, i.e. what happens to a sub n of a sequence in the long term. This is the notation that is coming up in calculus. The limit of a sub n as n approaches infinity is L. We say a sub n converges to L. Limit of a sub n as n approaches infinity is infinity or negative infinity or DNE. Does not exist. We say the sequence diverges. So, in short, convergent sequence means the limit is some number, it ends with some number. Divergent means it doesn't, it ends up with infinity, negative infinity, or we don't know, it oscillates, okay? Series and summation notation, summation rules. S sub n, the sum of a sub 1 plus a sub 2 all the way to a sub n of the first n terms of the sequence. So here's the sequence, and S represents the sum. The Greek letter sigma is the Greek letter sigma, and it indicates a sum. The sigma notation, summation of I going from 1 to n of a sub I, means add the terms a sub I beginning with the first term and ending with the nth term. I is called the index of summation. a finite series S sub n is a sub 1 plus a sub 2 all the way to a sub n. So summation of a sub I as I goes from 1 to n. An infinite series S sub infinity is a sub 1 a sub 2 all the way to a sub n, and it keeps on going. So summation of I going from to 1 just like that, and a sub I, this ends up at n, but this keeps on going to infinity. That's a finite series. It stops somewhere at n. This one doesn't, continues indefinite. So it's pretty straightforward, everybody. All right. So let's look at a simple example of that and to see what happens. What happens to a sub n of the following sequences? Let's calculate the first few terms. A sub n is 1 over n. So the first one is 1 over 1. The second one is 1 over 2.5. The third one is 1/3, and so forth. The 10th one is 1 over 10 or 0.1. So clearly it's going to 0. So you can see that this will end up, as n gets larger, 1 over n gets closer and closer to 0, and it's convergent. The answer is 0. If you were to plot that point by point, at x equals 1 is 1. And by the way, the x and y, they don't have to have the same scale. So a sub n equals 1 over n, and eventually it becomes 0. And if it was 1 over x, you would remember the graph of y equals 1 over x. Again, just reminding you, y equals 1 over x looks like that. These two pieces, okay? This is 1 over n, and n is just whole numbers. It looks like bunch of dots. All right, what about this one? Now, if I erase my work, if I put n equals 1, I get -1. If I put 2, I get positive. So as it appears, if n is odd, I get -1. If it's even, I get +1. And so the value seem to be alternating between -1 and 1. If that's the case, it doesn't set up, so the limit doesn't exist. It's divergent. The limit does not exist. And if you will graph it, it looks, points oscillates up and down, up and down. What about C7 equals n squared? Well, if I put 1, I get 1 squared of 1, 2, 4, 3, 9, 4, 16, 5, 25. So obviously it keeps on going and it tends infinity. Therefore, it makes it a divergent sequence. Summation properties is if a sub 1 all the way to a sub n and b sub 1 all the way to b sub n are two sequences, and c is a constant, is a number, is a multiplier, then for every positive integer n, the summation of c is n times c, because you're going to go from I equals 1 to n. If you have c times a sub I, you can take it outside the summation. If you have summation of a sub I plus minus b sub I, you can separate them into two. Okay, sum and difference. Summation of I, it's 1 plus 2 plus n, becomes n times n plus 1 divided by 2. Summation of I squared is 1 squared, 2 squared, and so forth, becomes n times n plus 1 times 2n plus 1 over 6. I cubed becomes n squared times n plus 1 squared over 4. We will need that for calculus. We will discuss that. When we get there, I'll go over that again in calculus. You need this stuff. All right, let's actually put this to a use. And this is the synopsis of what we discussed. We want to find the summation of 2 to the power of k plus 1 as k goes from 1 to 6. Well, we start with 1, 2 to the power of 1 plus 1, then 2, 2 squared plus 1, 2 cubed plus 1, and we end up with 2 to the power of 6. So we add up all the way to the last one. This one, everybody, is the last one. And it's important to see that we have it. So the last. And at this point, all you have to do, just do the math. For example, let's write it. This is 3. This is 4 and 1, 5. This is 8 and 1, 9. And this is 16 and 1, 17. This is 32 and 1, 33. 64 and 1, 65. You add them up and you end up with 132. What about this case? We start with the bottom 3, so we write a sub 3, and then 4, 5, all the way, and we stop at the top number, the top limit, which is 6. What about this one? If you want, you can take the 5 out and write equals 5 summation I going from 1 to 40 of 1, if you want to write this. And this is n times c, so 40 times 1. So this is 40 times 1, and then times 5. Or just say 40 times 5, according to this one. 40 times 5. And the answer is 200. So let me actually erase mine so it becomes easier to read. So according to this one, 40 times 5. And that's very straightforward, everybody. What about this one? Well, we can take the 2 out and then use the fact that the summation of I has this formula. So use this one. So 2 remains as a multiplier, and this is n times n plus 1 over 2, where n is 22, everybody. So for this question, n is 22. Therefore, it's 2 times n, which is 22, times 22 plus 1 divided by 2. This cancel this one. 20 times 23 is 506. What about this one? And remember, this is the top one. We're going to cut this into pieces. How do we do that? For this one, we take the 2 out and we get I squared. This one is just 3. So if you do it as such, makes it easy. And so for I squared, we will use this one. And for this one, we use this one. Let's quickly go over that. 2 times the summation of I going from 1 to 14 I squared. So we're going to write 2 times, and I'm going to go with n. N is 14, everybody. Same thing here. So 2 times n, which is 14 times 14 plus 1 times 2 times 14 plus 1, divided by 6 for this part, and this one minus summation of n 14 times c, which is 3. So that's pretty straightforward, everybody. Two goes away. This becomes 3. And this is 28. So we have 14 times 15 times 29 minus 42. And this is 5. 14 times 5 times 29 minus 42 ends up being 1988. So I hope it's pretty clear to everybody. All right. Let's go with this example, summation of k over k plus 1. K goes from 1 to n. So first you replace the k with 1. You get 1 over 1 plus 1. Then 2, 2 over 2 plus 1. 3, 3 over 3 plus 1. And all the way to n over n plus 1. So write out each sum. We're just writing it out. That's all they're asking. What about this one? You're going to write 1 squared minus 1, 2 plus 2 squared minus 1, 3 squared minus 1, 4 squared minus 1, n squared minus 1, all the way. So that, of course, this can be evaluated easy, but eventually you stop. So n squared minus. So expanding the summation is pretty easy. Going back, sometimes it's not easy. Sometimes it's doable. Okay, and that's important to understand. Sometimes it's not a problem at all. Sometimes it can be frustrating because it can't be done at all. Okay. All right, so let's see what happens here. Can we figure this out? That's what we are trying to do. Well, notice it's one squared, two squared, three squared. So just summation of something, k, n, something squared, and we start from one and we end up with 9. So I hope you recognize summation of k squared. You can say I squared, I going from 1 to n, but this is pretty straightforward. What about this one? So 1, 1/2, 1/4, 1/8. It appears the numerator is 1. So summation, the numerator is 1. But what is the denominator? Let's write this one as 1/1. So the denominator is the one that is changing 1, 2, 4, 8 to the power of n minus 1. So actually, it's giving you the answer. The answer for the denominator is 2 to the power of n minus 1. And notice if you choose n to be 1, the denominator becomes 2 to the power of 0, which is 1. If you choose it to be 2, 2 minus 1 is 1, 2 to the power of 1 is 2. And so basically, this is your general term, and k goes from 1 to n. Again, that's pretty straightforward, everybody. What about this one? We want to evaluate it, k equals 1. So replace the k with 1. 3 times 1 plus 3 times 2, 3 times 3, all the way to this number 5. That's the concept. And you can do it by hand because 5 is small. But if we want to go with the general case, first we take the 3 out, and this one, everybody, uses this one. Summation of I or k. I and k, they are dummy variables, class, okay? So I can summation of, I can say summation of j going from 1 to 5, it has the same meaning. So the 3 remains, and inside, if we follow that, becomes n times n plus 1 divided by 2, where n is 5. So 5 times 5 plus 1 divided by 2. And this is 6. With 2 goes away with 3. And you get 3 times 5 times 3. 3 times 15, making it 45. So again, I believe it's pretty straightforward, everybody. We want to evaluate this summation. We cut it into 2 pieces, this piece and this piece. And for that, remember, we can cut it into pieces because if the summation of a sub I plus minus b sub I are given, you can cut them into, so the sum of the summation of the sum is the sum of the summations, or the difference, the sum of the difference is the difference of the summation. So I can put this into 2 different ones as follows. And for this one, I'm going to go for this one. And I'm going to write n squared, which is 10 squared times n plus 1, which is 10 plus 1 squared over 4. And for this one, I'm going to go with that. So I'm going to use that one. And this one, of course, is just summation of 1. So that means 1 times 10. Again, it's pretty straightforward, everybody. So this one is 100. Cancels out the 4. 25. This is 11 squared. This is 10. So 11 squared is so 121. You plug in, you get 3025 plus 10 equals 3035. What about this one? We are going to do exactly the same. We are going to cut them into pieces. And by that, I mean this piece, and this piece as follows. So what are we going to use? Let me erase my work. For this one, for this one, we are going to use number 5. So number for this one, we are going to use number 4. For this one, we are going to use number 1. So starting with this one, and remember n is 24. So n 24 times 24 plus 1 times 2 times 24 plus 1 divided by 6. This one minus 7, summation of k, we use 4. N, which is 24 times 24 plus 1 over 2. And finally, 2, simply 2 times 24. You put them into a calculator. The first one becomes 4,900. This becomes negative 2,100. This becomes 48. They add up to 2,848. The last piece is the factorial symbol. If n is larger than or equal to 0 is an integer, the factorial symbol n factorial is defined as follows. N factorial is n times n minus 1 times n minus 2. So all the way to 1. 0 factorial is 1. 1 factorial is also 1. For example, if we want 5 factorial means 5 all the way to 1. 5, 4, 3, 2, 1, multiply. 5 times 4 is 20 times 3. 60 times 2 is 120. 7 factorial means 7 all the way to 1. Multiply 7 all the way to 1. That's the meaning of it, everybody. And so you multiply and you get 55,040 in essence. Now, if the number gets larger and larger, it's better to use a calculator and understand that. But we should understand the concept. So for factorial, you enter the value of n, then press math, then select PRB, and then select the factorial sign and enter. So over here, enter the value of n, then PRB, then factorial, and so math, PRB, factorial. And we have NPR, NCR, those are combinations and permutations. So for example, 5 factorial, we put it, we get the answer. Okay, as an example, it's easy to do. Now, if we want to simplify, and again, you could use a calculator, but can it be done without a calculator? And I'll show you a fairly easy methodology for a case like that. When you want to do the division, you look at the bottom and the top, and you see that this one is larger. So this one is 12 times 11 times 10 times 9 times 8 all the way to 1. This is 10 times 9 times 8 all the way to 1. So you keep the smaller one unchanged, and the top one you say 12 times 11 times 10, and stop 10 factorial, because this now can cancel this. 12 times 11 equals 132 is the final answer. And we are done, everybody.